Okay, hello everybody. Welcome to this Mathematics Edexcel, Monday the 8th of June 2020, paper 3. It's a calculator paper. It's a higher tier paper. Let's get to it. So 1a, simplify n to the power of 3, multiply by n to the power of 5. So if we go to the cheat sheet, we're going to use the multiplication rule for this one. And if you're unsure what that is, the multiplication rule is when we have the same base, so two a's. We have a to the power of x, multiplied by a to the power of y. And in this case, we're just going to add those two powers together. So that's going to give us a to the power of x plus y. So we have n to the power of 3 multiplied by n to the power of 5. So we're going to use that multiplication rule and add those powers. So it's going to be n to the power of 3 plus 5, and that is going to give us n to the power of 8. Part B, c to the power of 3 multiplied by d to the power of 4, all divided by c squared multiplied by d. So if we go to the cheat sheet, we're going to use the division rule for this one, but we're going to use them separately for c and d. We're going to keep those, the c values and the d values separate. And again, if you're unsure about the division rule, it's very similar to the multiplication rule, where we have the same base, again with a, but a to the power of x divided by a to the power of y, it's going to be a to the power of x minus y. So in the multiplication rule, we add, in the division rule, we subtract. Okay, so it's going to be c to the power of 3 divided by c to the power of 2. So that's going to be c to the power of 3 minus 2 multiplied by d. Well, we have d to the power of 4 divided by d, which is the same as d to the power of 1. So that's going to be 4 minus 1. Well, c to the power of 3 minus 2 is going to be c to the power of 1 multiplied by d to the power of 3. 4 minus 1 is 3. C to the power of 1 is just 3. And then we keep this d to the power of 3 as it is. And we just put them together like this. Part C, 5x divided by 2 is greater than 7. So if we go to the cheat sheet, we're going to aim to get x on its own. We're going to try and get everything on one level. And then we're going to divide through to get x alone. Okay, so what I'm going to do here, I want to try and get rid of this 2. So just going to multiply by 2 on both sides. And that's going to give us 5x is greater than, well, 7 times 2 is 14. I'm going to divide through by 5. To get x alone, so 5 multiplied by 5, they're going to cancel out. X is greater than 14 over 5, and you could just leave it like that for your answer. Question 2, Andy cycles a distance of 30 kilometers at an average speed of 24 kilometers an hour. He then runs a distance of 12 kilometers at an average speed of 8 kilometers an hour. Work out the total time Andy takes. Give your answer in hours and minutes. Okay, so if we go to the cheat sheet, we're going to remember that speed equals distance over time. And something to be very careful here, we need to be careful with time, so don't confuse minutes and hours in this question. Okay, so for questions like this with speed, distance, and time, you should remember that we have speed equals distance over time, and we're going to use this triangle throughout this question. I'm also going to draw in what we know. So, for example, he cycles a distance of 30 kilometers, so let's just put that in there, put that in blue. At an average speed of 24 kilometers an hour, just put that down here. And then when he starts running it in green, he runs a distance of 12 kilometers, so let's put that in here. At an average speed of 8 kilometers an hour. Okay, so we know that when he's cycling, we know the speed, we know the distance, we don't know the time. So we're going to use this now. So if we're looking for the time, it's going to be distance over speed. So t equals distance over speed. The distance is 30. Speed is 24. This can be broken down to 5 over 4 if we divide top and bottom by 6. So this is going to be the same as 1 1/4 hours, or 1 hour 15 minutes. And when he starts running, we know that the speed is 8 kilometers an hour. We know that the distance is 12 kilometers. What is the time? Well, t is going to equal d over s. d is 12. S is 8. And this is going to equal 3 over 2, which is the same as 1.5. 1.5 hours, which is the same as 1 hour 30 minutes. So we have, when he's cycling, it takes 1 hour 15 minutes. When he's running, it takes 1 hour and 30 minutes. We just need to add those together to give us 2 hours 45 minutes. Question 3, a number m is rounded to one decimal place. The result is 9.4. Complete the error interval for m. So if we go to the cheat sheet, a tip here is going to be, so if we have 9.44, we are going to round down to 9.4. However, if we have 9.45, even though it is right in the middle of 9.4 and 9.5, we are going to round up to 9.5. So if it's right in the middle, we always round up, not down. So we have to one decimal place, so we have 9.3, 9.4, which is what we want, and 9.5. So I've got this solid line here, which is right in the middle of these two, which is 9.35. This is going to round up to 9.4. However, if we had something slightly lower than that at 9.34, this would round down. And here we have 9.45, and I've deliberately put this in a dashed line, because this will round up to 9.5, not down to 9.4, because it's right in the middle. But anything less than 9.45, say like 9.44, 9.43, 9.42, so on and so on, they will round down to 9.4. So the answer here is going to be 9.35 is less than or equal to m. And 9.45 is, well, m is less than 9.45. It's not equal to it, but it is less than. Question 4. Maisie knows that she needs 3 kilograms of grass seed to make a regular lawn 5 meters by 9 meters. Grass seed is sold in 2 kilogram boxes. Maisie wants to make a rectangular lawn 10 meters by 14 meters. She has 5 boxes of grass seed. Part A. Has Maisie got enough grass seed to make a lawn 10 meters by 14 meters? You must show all your working. So if we go to the cheat sheet, I think we should probably do this one in stages. So I'm going to do this first part. So how many meters squared, how much area for 1 kilogram of grass seed? Okay, so from the question, we know that she needs 3 kilograms of grass seed to make a rectangular lawn 5 meters by 9 meters, which we have here. Well, if we want to work out this area, we need to multiply the 5 by the 9. So it's going to be 5 multiplied by 9, and that's going to give us 45 meters squared, which I'm going to put in here. And we know that there's 3 kilograms of grass seed needed for this 45 meters squared. So what I'm going to do now, I'm going to say the 45 meters squared divided by the 3. That's going to give us 15 meters squared, and that is going to be for 1 kilogram of grass seed. So we can take up part 1 of the cheat sheet. Now we go to part 2. We need to work out the size of the lawn Maisie wants to make in meters squared. Okay, so from the question, we know that she wants to make a lawn of 10 meters by 14 meters, which I put here. So we're going to do, to find out this area, it's going to be 10 meters by 14. That's going to give us 140 meters squared, which I'll put right here. We can now check this off on the cheat sheet. So part 3 of the cheat sheet, how many kilograms of grass seed does she have? Remember, she has 5 boxes of 2 kilograms of grass seed. So for the amount of grass seed, it's going to be 5 boxes of 2 kilograms in each box, and that's going to give us 10 kilograms of grass seed. So we can check that off. Then we need to ask, well, what size lawn can she make with this? So we know that for 1 kilogram of grass seed, you can get 15 meters squared of area just from 1 kilogram. How much can we get with 10 kilograms? So we can say that it's going to be 10 kilograms multiplied by those 15 meters squared for 1 kilogram of grass seed. And that's going to give us 150 meters squared worth of lawn. And to summarize our answer, we can say as 150 meters squared is greater than 140 meters squared, yes, Maisie has enough grass seed for a lawn 10 meters by 14 meters, which would be 140 meters squared. Maisie opens 5 boxes of grass seed. She finds that 4 of the boxes contain 2 kilograms of grass seed. The other box contains 1 kilogram of grass seed. Part B. Does this affect whether Maisie has enough grass seed to make her lawn? Give a reason for your answer. So if we go to the cheat sheet, well, she's now going to have 4.5 boxes because she has 4 whole boxes and 1 half a box. So she has 4.5 boxes. So Maisie now has 9 kilograms of grass seed, not 10 kilograms of grass seed. So we know that 4.5 boxes of 2 kilograms of grass seed are going to give us 9 kilograms of grass seed. This 9 multiplied by the 15 meters squared that we found in part A is going to give us a total of 135 meters squared. And for your answer, you could say as 135 meters squared is less than 140 meters squared required for the lawn. Yes, this will affect whether Maisie has enough grass seed to make her lawn. And in brackets, she won't have enough. Question 5. Amanda has 2 fair 3-sided spinners, which you have here, spinner A, spinner B. Amanda spins each spinner once. Complete the probability tree diagram. So if we go to the cheat sheet, fair-sided is going to mean that all sides have the same probability of it landing on that number. And for part 2, the probability of not 2 is going to equal the probability of 1 plus the probability of 3. Okay, so as the spinner is fair-sided, we know that the probability of landing on 1 is going to be 1 in 3. The probability of landing on 2 is 1 in 3. The same with probability of 3, again, 1 in 3. So now we need to find the probability of not 2. Well, this is just going to be the probability of 1 plus the probability of 3. So it's going to be a third plus a third. And for this, we just add the 2 on the top. So it's going to be 2 thirds. And now it's nice and easy. We know that the probability that it lands on a 2 is going to be a third. The probability that it does not land on a 2 is going to be 2 thirds. So we just need to fill that in. And there we go. On to part B. Part B, work out the probability that spinner A lands on 2 and spinner B does not land on 2. So if we go to the cheat sheet, to get our answer, it's going to be the first pick multiplied by the second pick, and that is going to give us our answer. We're going to multiply the numerators, multiply the denominators. So again, from the question, we need to work out the probability that spinner A lands on a 2. So it's going to be this way. And spinner B does not land on 2. So it's going to be this way. And that probability is going to be a third multiplied by 2 thirds. So 1 over 3 multiplied by 2 over 3. And when we multiply fractions, we just multiply the top, multiply the numerators. That's going to be 1 by 2 is going to be 2. Multiply the denominator, so 3 by 3 is going to be 9. And that is our answer. So question 6, part A, use these graphs to solve the simultaneous equation. So we have 5x minus 9y equals minus 46, and y equals minus 2x. So if we go to the cheat sheet, we need to find the point where they intersect on the graph. And we need to get the x and the y values. So the point where they intersect is going to be here. So for the x value, it's going to be -2. For the y value of the stairs, it's going to be number 4. Part B, use this graph to find estimates for the solutions of the quadratic equation x squared minus 4x plus 2 equals 0. Okay, so in the cheat sheet, the solutions are the values of x where the curve crosses the x-axis. So where does it cross the x-axis? Well, we're looking at here, and we're looking at here. So if we look very closely, I think this is 0.6. So x equals 0.6. And here, I think this one is 3.4. So x equals 3.4. Question 7, there is a total of 45 boys and girls in a choir. The mean age of the 18 boys is 16.2 years. The mean age of the 27 girls is 16.7 years. Calculate the mean age of all 45 boys and girls. So if we go to the cheat sheet, well, the overall mean is going to be all of the ages divided by all of the people. Part 2, all of the ages is going to be all of the boys' ages plus all of the girls' ages. And then all of the people is going to be the 18 boys plus the 27 girls. So the mean overall age is going to be all of the ages added up, which I'm going to focus on now, divided by the total number of people. But for all of the ages, well, we know that the average age of the boys, the mean age of the boys is 16.2, and we know that there are 18 boys. So all of the ages of the boys is going to be 18 multiplied by 16.2, put that in brackets, plus all of the ages of the girls, which is going to be 27 girls, multiplied by 16.7, the mean age of the girls. And we're going to divide this by the total number of people, which is going to be the 18 boys plus the 27 girls. And if you work this out on your calculator, that's going to give you 742.5 divided by 45. And again, if you work that out on your calculator, that's going to give you an average age of 16.5 years. Question 8, there are some counters in a bag. The counters are blue or green or red or yellow. The table shows the probabilities that a counter taken at random from the bag will be blue or will be green. And we have that table here. The probability that a counter taken at random from the bag will be red is 5 times the probability that the counter will be yellow. There are 300 counters in the bag. Work out the number of yellow counters in the bag. So if we go to the cheat sheet, well, I'm just going to split this here. We'll do the first 3 to begin with. So the probability of all colors is going to equal 1. Part 2, what is the probability of red plus yellow? And then we're going to split this into parts. So the probability for red and yellow is going to be 1, which is the total probability of all of this, minus the 0.32 for blue, minus the 0.20 for green, and this is going to leave us with 0.48. And remember from the question, we are given that the probability of red is 5 times the probability that it will be yellow, which we have here, and that's going to give us a total of 6 parts. And we have a probability of red plus yellow as 0.48, but we're going to split this into 6 parts. So how many 6s into 0? That's 0. The point there. How many 6s into 4? That's 0 if we carry the 4. How many 6s into 48? Well, that is going to be 8. And if you remember your ratio of 5 to 1, so we know that the probability of red is going to be this 0.08 from here, multiplied by 5, which is going to give us 0.4. And for yellow, just put that in, 0.4, 0.40. And for yellow, it's going to be 1 part, so it's going to be 0.08 here, multiplied by 1, which is just going to give us that 0.08 again. And now if we go to the cheat sheet, we've done the first 3, and actually we've done part 4. Also, we use the parts for red and yellow, and the ratio. Now for part 5, we need to multiply this probability for yellow by 300 to find the number of yellow counters. So you're going to probably need your, well, you will definitely need your calculator for this. So it's going to be 300 multiplied by 0.08. And that is going to give us a total of 24 yellow counters. Question 9, the diagram shows a prism, which we have here. The cross-section of the prism, which is this front part here, or you could say this back part here, it has exactly 1 line of symmetry. Work out the volume of the prism. Give your answer correct to 3 significant figures. Okay, so if you look at the cheat sheet, the volume of the prism is the area of the cross-section multiplied by the height. Part 2, we're going to split the cross-section into a rectangle and a triangle. And then we're going to split the triangle in half, and we're going to use trigonometry. We're going to use SOHCAHTOA to find the height, to try and find the area of these 2 triangles. So the volume of the prism is going to be the area of the cross-section, which, like I've said, is this part at the front here, or this part at the back, multiplied by the length. Well, I'm going to split this into 2. So we've got this rectangle, and we've got this triangle up here. So with the rectangle, we know that this is going to be 12 multiplied by 10. And the area of this is going to be 12 multiplied by 10, which is going to give us 120 centimeters squared. Just put that in. So now we've got to work out the volume of this triangle, and it does say in the question that it does have 1 line of symmetry, which I've put in as this green dotted line, both on the triangle and on the rectangle. So this means that we can make 2 right-angled triangles with this 1 triangle. So for half of this triangle, we have this 10 centimeters is going to become 5 centimeters because that is half of 10. We're going to keep this 40 degrees from here. We're going to have this right angle. And remember, we're going to work out this, the area of this, using trigonometry, but we're also going to multiply by 2 because we have 2 of these triangles of exactly the same size. So to remember, to work out the area of a triangle, we need the base multiplied by the height, and then we divide it by 2. So we're looking for this height. We have the base of 5. We're looking for x. So what do we have here? Well, we have the 40 degrees. We have the angle that is adjacent to the angle, and then we have the angle that is opposite. And because we have the opposite and the adjacent, we are going to use tan. So we're going to have tan theta equals the opposite over the adjacent. Well, the angle here is 40, so it's going to be tan 40. The opposite is x. We don't know what that is yet, but the adjacent we do know. It's going to be 5. We're going to multiply both sides by 5 to give us 5 tan 40 equals x. So using the calculator, that is going to give us x as being 4.1954, which I'm just going to put in here. So the area of this half of this main triangle here is going to be the base multiplied by the height divided by 2. Well, the base is 5. The height is 4.1954, and so on and so on. We're going to divide this by 2. And that is going to give us 10.4887 and so on centimeters squared for this triangle here. And given that this triangle here is exactly the same as this, we're going to multiply this by 2 to give us the area of this triangle. So if we go back to the original question, the volume of the prism, well, for the area of the cross-section, it's going to be the square plus the triangle multiplied by the length. The length here is going to be 20, so we can put that in. So that is going to be the 120 centimeters squared for the rectangle plus the 20.9774 centimeters squared for this triangle multiplied by 20. And that is going to give us a total of 2,819.549816 centimeters cubed. And in the question, it does ask for this to be the 3 significant figures. So it's going to be 2,800. Well, this 19 we are going to round up because of this 0.5. We're going to round it up to 20. So it's going to be 2,820 centimeters cubed. Question 10. A person's heart beats approximately 10 to the power of 5 times each day. A person lives for approximately 81 years. Part A. Work out an estimate for the number of times a person's heart beats in their lifetime. Give your answer in standard form. So I'm just going to underline this. Correct to 2 significant figures. So if we go to the cheat sheet, the keyword here is estimate. I'm just going to underline that again. So we have estimate. So it doesn't need to be perfect. That's really important to note. And if we're going to try and find the number of times in a lifetime, well, it's going to be 10 to the power of 5 multiplied by the 365 days in a year, multiplied by the 81 years that we have. We're going to round that to an easy number. And then when we put it in standard form, we need to remember that the A, when we have something multiplied by 10 to the power of something, this A needs to be between 1 and 10. So it needs to be greater than or equal to 1, but less than 10. Okay, so we need to work out how many times the heart beats in a person's lifetime. Well, we know that it beats 10 to the power of 5 times per day. We know that there are 365 days in a year, roughly. Well, sometimes you have a leap year, but this is an estimate, remember. And that a person lives for approximately 81 years, so we're going to multiply that by 81. And that is going to give us 2,956,500,000 beats in a lifetime. Now we need to, because it's an estimate, we need to round it to something. It doesn't have to be perfect. So I'm going to round that. It's quite close to 3 billion, so I'm going to put it as 3 billion for now. That's a better estimate than this. It's a lot easier. But it also asks for the answer to be in standard form and correct to 2 significant figures. So remember, this needs to be between, the number needs to be between 1 and 10. So I'm just going to change this to red. Well, we have this 3, so I'm going to put 3 here. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to put 3 times 10 to the power of 9, which would be fine, but it does ask us to give it to 2 significant figures. So what I'm going to do here, I'm going to put 3.0 times 10 to the power of 9, and that is our answer. So for part B, we are given that 2 multiplied by 10 to the power of 12 red blood cells have a total mass of 90 grams. Part B, work out the average mass of 1 red blood cell. Give your answer in standard form. So if we go to the cheat sheet, we're going to divide both sides by 2 multiplied by 10 to the power of 12 to find the value of 1 red blood cell. So we are given in the question that 2 multiplied by 10 to the power of 12 red blood cells equal 90 grams. So I'm going to reflect that here. But we are asked to find 1 red blood cell. So how do we make this into 1? Well, we are just going to divide both sides by 2 times 10 to the power of 12. So that is going to give us the 2 times 10 to the power of 12 divided by the same number. Well, they are just going to cancel out to give us 1. And that is going to give us 90 over 2 times 10 to the power of 12. And if you do this on your calculator, you will get 4.5 times 10 to the power of minus 11. Question 11, the diagram shows a triangle P on a grid, which we have here. Triangle P is rotated 180 degrees about 0, 0, which is just here, the center point, to give triangle Q. Triangle Q is translated by a vector of 5 minus 2 to give triangle R. Part A, describe fully the single transformation that maps triangle P onto triangle R. So if we go to the cheat sheet, well, if we are rotating, we really should be using tracing paper for this to get to Q. Or if it's this only works if it's 180 degrees. If it's a 180 degree rotation, we could reflect in the x-axis and then reflect in the y-axis. Now we'll show you this in the example. And for translation, I like to think of it as it's kind of like teleporting the shape to, it stays exactly the same, but we just move it. We teleport it to another area of the graph using the vector given. Okay, so first of all, we have triangle P. I'm going to try and get this into triangle Q by rotating 180 degrees about 0, 0. Again, like I said, you really should be using tracing paper and then rotating it around like this. But another trick you can use is, and I've just put these points on the triangle in different colors, you can reflect it in the x-axis and then reflect that into the y-axis to get where the point is now. For example, if we were to reflect this red point here in the x-axis, well, it's 2 away from the x-axis, so I'm going to go 2 below. So it's 2 above here. We're going to go 2 below here just to go to here. And then we need to reflect it in the y-axis here. So it's 1 to the right of the y-axis, so it's going to become 1 to the left. And that is going to be the new point of the red on triangle Q. We're going to do the same thing for the blue point, so that is 5 up from the x-axis, so we're going to go 5 down to here, and then it's 1 away from the y-axis, so it becomes 1 to the right, now it becomes 1 to the left. Same with the green point, down to 5, and then 2, it becomes here. And now for the point to get triangle R, so we need to use triangle Q, which is here, and we're going to translate it by the vector, well, it's going to be 5, positive 5 on the x-axis, and minus 2 in the y-axis. So again, using this red point, we're going to go 5 along, so it goes from minus 1 to 4, on the x-axis, and then it's going to go down to here on the y-axis. If we find the blue, again, we're going to go along 1, 2, 3, 4, 5, and then down 2 to here. And then with the green, we're going to go 1, 2, 3, 4, 5 along the x, and then 1, 2 down. So now that we have triangle R, it does say describe fully the single transformation that maps triangle P onto triangle R. Again, you really should be using tracing paper for this, but if you did that, your center point would be here. So this is going to be a rotation of 180 degrees clockwise. You could also say anti-clockwise because it's the same thing. It's 180 degrees. And this is going to be about the point 2.5 on the x-axis and minus 1 on the y-axis. So under the transformation that maps triangle P onto triangle R, the point A is invariant. Write down the coordinates of point A. So if we go to the cheat sheet, well, invariant, if you're not sure, it means that something that doesn't change or doesn't move. So if we look at triangle P and triangle R, well, all of these points on the triangle have moved dramatically. Therefore, the only possible value it could be is this point here, the center of the rotation. This is the only point that will stay exactly the same. It doesn't matter where you move it to. So therefore, this is going to be 2.5 minus 1. Question 12a, express x over x plus 2 plus 2x over x minus 4 as a single fraction in its simplest form. So if we go to the cheat sheet, well, we're going to try and aim to get the two fractions into 1. Try and get the same denominator on both sides to make this fraction into 1. And to do this, we're going to multiply the opposite denominator on one fraction and the opposite denominator on the other fraction to get the same fraction, the same denominator. Okay, so what we're going to do, we've got this x over x plus 2, and then there's 2x over x minus 4. I'm going to multiply x minus 4 by the top and bottom of this fraction here. So it's going to be x over x plus 2, multiplied by x minus 4 on the top, x minus 4 on the bottom, which keeps it all equal, doesn't change anything. Then we have plus, I'm going to change this to blue, and I'm going to multiply this x plus 2 by the top and the bottom of this 2x over x minus 4. So it's going to be 2x over x minus 4, multiply this x plus 2 over x plus 2. And again, we're multiplying the top and the bottom by the same thing, so it doesn't change anything. It doesn't cause any imbalances. Okay, so when we multiply a fraction, we multiply the numerators together, we multiply the denominators together. So x multiplied by x is going to be x squared. X by minus 4 is going to be minus 4x over, well, we've got x plus 2, x minus 4. Just going to leave that as it is for now. Plus, and I'll just change this to blue. So we've got 2x multiplied by x, which is going to give us 2x squared. 2x multiplied by 2 is going to be plus 4x. All divided by, we've got x minus 4, x plus 2. Or you could just flip those around to change the order and say it's x plus 2, x minus 4. It's the same thing. So now we've got the same denominator on both sides. What we can now do, if I just change this to green, well, we can put the whole thing together. We have this x squared minus 4x plus 2x squared plus 4x. And this is all going to just be over x plus 2, x minus 4. So we have this x squared plus 2x squared, so that's going to leave us with 3x squared. We can just cross those out. We have minus 4x plus 4x, and that's going to leave us with 0. And then we can just put x plus 2, again, x plus 4. No need to multiply those brackets out. And that is our answer. Part B, expand and simplify x minus 3, 2x plus 3, 4x plus 5. So if we look at the cheat sheet, do not be overwhelmed by the 3 brackets. It's just the same as if we had 2, but we just have an extra one to multiply out. So what I would recommend you do is here, if you look at part 2, we're going to focus on multiplying our bracket 1 and bracket 2 first, and then we can add in multiply bracket 3 at the end. Okay, so just to begin with, like I said from the cheat sheet, we're going to just focus on these first 2. So I'm going to put these in blue. So we have x minus 3, 2x plus 3. And I'm going to put this 4x plus 5 in red because we're going to deal with that later. So if we multiply out these blue brackets, well, x by 2x is going to give us 2x squared. X by plus 3 is plus 3x. Minus 3 by 2x is going to give us minus 6x. Minus 3 by plus 3 is going to give us minus 9. And then I'm just going to add that bracket on at the end. Just tidy up this. So we have 2x squared plus 3x minus 6x is minus 3x minus 9. And then again we have that 4x plus 5 at the end. Let's change to red now. So this 2x squared by 4x is going to be, well, we multiply the number, so that's going to be 2 by 4 is 8. Multiply the x values, that's going to be x squared by x is going to be x cubed. 2x squared by plus 5 is plus 10x squared. Minus 3x by 4x, that is going to be minus 12x squared. Minus 3x by plus 5 is going to give us minus 15x. Minus 9 by 4x, that's going to give us minus 36x. That's a little untidy. Minus 9 by plus 45 is going to give us minus 45. And now we're just going to collect the like terms. So we only have this for x cubed. So we have 8x cubed, done. We have plus 10x squared minus 12x squared. So that's going to give us minus 2x squared. We can cross those out. We've got minus 15x minus 36x. That's going to be minus 51x. Cross those out. And then the minus 45 at the end. We can cross that out as well. And there we go. That is our answer. Question 13 there. On the grid, show by shading the region that satisfies all these inequalities. So we have x is greater than or equal to 0. X is less than or equal to 2. Y is less than or equal to x plus 3. Label this region R. So if we go to the cheat sheet, to begin with when we're sketching, we're just going to ignore these inequalities. So for example, if we have y is less than 2x or something like that, we would just ignore that inequality and we're going to imagine it's y equals 2x, and that is what we're going to draw. We're going to get these equations into y equals mx plus c form. This will help us draw the line, make it a lot easier. And when we are sketching the lines, it should be a solid line if we have less than or equal to something or greater than or equal to something, like this. But if it was, let's say, less than, greater than, or less than, we would do a dashed line because anything on this line would not satisfy the inequality, whereas anything on this solid line, because it's greater than or equal to, anything on this line, anything equal to this line would count. It would be part of the equation. It would satisfy it. And part 4, to check which side of the line is going to satisfy the equation, we're going to pick a point on one side of the line and we're going to sub it into the equation. And if it's correct, we know that this side of the line is good. If it isn't, we know that it's bad and we can shade it out. Okay, so we have x is greater than or equal to 0. So again, we need a solid line because it's greater than or equal to. So I'm going to put this into red. And then same again, nice and easy. X is less than or equal to 2. So just think of x equals 2. And then we have y is less than or equal to x plus 3. Well, we know that it's going to be the gradient of 1. So it's going to go along 1, up 1, along 1, up 1. And we know it's going to cross the x-axis at plus 3. Okay, so for the first inequality, well, x is greater than or equal to 0. So anything less than x, anything less than 0 is not going to count for this inequality. And then we've got x is less than or equal to 2. So anything greater than 2 on the x-axis is not going to count. So we need to shade that out. This last one's a little bit trickier. So we've got y is less than or equal to x plus 3. So we've got this line here, this green line. I don't know whether I need to shade this side of the line or this side of the line. So what I'm going to do, I'm going to pick a random point here, and that is going to be when x equals 1 and y equals 7. So we have y is less than or equal to x plus 3. Well, y is going to be 7. Less than or equal to, we have 1 for x plus 3. So 7 is less than or equal to 4. Well, no, 7 is greater than 4. So this is incorrect. So all of this side of the line is incorrect. And then I've left this one to the end because it can be a little bit more tricky. And I want to get this one into y equals mx plus c form. So, okay, I'm going to subtract the 2x from both sides to give us 3y is greater than or equal to 6 minus 2x. Then I'm going to divide both sides by 3 to get y on its own. So that's going to be 6 minus 2x divided by 3. It's going to be y is greater than or equal to 6 divided by 3 is going to be 2. Minus 2x divided by 3 is going to be minus 2/3 x. And then we can just flip these around to get it into y equals mx plus c form. So it's going to be minus 2/3 x plus 2. And this is going to be our line for 2x plus 3y is greater than or equal to 6. So is this side of the line going to satisfy the inequality, or is it this side? So I'm just going to pick a random point. I'm going to pick this one here. So we have x equals minus 1, y equals 1. So we're going to sub those values into the equation. So it's going to be 2 multiplied by minus 1 plus 3, and this y is going to be 1. It's greater than or equal to 6. Well, 2 multiplied by minus 1 is minus 2, plus 3 is greater than or equal to 6. Minus 2 plus 3 is, that's going to be plus 1, is greater than or equal to 6. Well, this is incorrect. 1 is clearly less than 6, so this side of the line is going to be incorrect. And I'm going to label this region R. Part B, the diagram below shows the region S that satisfies the inequalities. Y is less than or equal to 4x, y is greater than or equal to a half x, x plus y is less than or equal to 6, and we have this information here on the graph. Jeffrey says that the point with coordinates 2, 4, I'm just going to mark that in now, so we have 2, 4, it's bang on the line, really important that is bang, bang, bang on the line. Does not satisfy all the inequalities because it does not lie in the shaded region, so inside the shaded region. Is Jeffrey correct? You must give a reason for your answer. So if we go to the cheat sheet, well, as I mentioned in part A, if it's less than or equal to or greater than or equal to, anything on the line satisfies the inequality. And for part 2, anything where it's clearly less than or clearly just more than and not equal to, anything on the line does not satisfy the inequality. So for our answer, we consider, well, as a point 2, 4 satisfies the line x plus y is less than or equal to 6 because it's on the solid line. No, Jeffrey is not correct. Question 14, the points B, D, E, and F lie on a circle. You can see that here. A, B, C is the tangent to the circle at B. You find the size of the angle A, B, D. You must give a reason for each stage of your working. So if we go straight to the cheat sheet, well, the opposite angles in a cyclic quadrilateral are going to add up to 180 degrees. That's something to bear in mind. The angles in a triangle, you should know this one, really important. The angles in a triangle add up to 180 degrees. And part 3, we're going to use alternate segment theorem to find the angle A, B, D. Okay, so straight away I can say this angle DBF, well, this is opposite this 100-degree angle here, and this is a cyclic quadrilateral because all 4 of this of the sides, they touch the circumference of the circle. So I know that DBF is going to equal 80 degrees because the opposite angle is 100, and these must add up to 180 degrees. So we can write something like this. And now I can see a triangle here, so from DBF, I can see we've got a 40-degree angle, an 80-degree angle, and now we have, we're going to have a 60-degree angle because these 3 angles, they must add up to 180 degrees, and we're going to write something like this. And now we know that the angle ABD, which is here, is going to be equal to the angle BFD as a result of the alternate segment theorem. Just going to put this down here. So we know that the angle ABD is equal to 60 degrees. Question 15, prove algebraically that 0.73 recurring can be written as 11 over 15. So if we go to the cheat sheet, the idea here is to try and get rid of the recurrent part. And for example, 10x is going to equal 7.3 recurring, 100x is going to equal 73.3 recurring, and 100x minus 10x is going to give you 90x. Okay, so x equals 0.7 with the 3 recurring. 10x, well, we're just going to move this decimal point to here. So that's going to give us 7.3 recurring. And with 100x, well, this point here is going to go 1, 2 to 73.3 recurring. So we just switch to red. Well, if we go 100x minus 10x, this is going to equal 73.3 recurring minus 7.3 recurring. Well, 100x minus 10x is 90x. 73.3 minus 7.3 is the same as 66. We're going to divide both sides by 90 to get rid of, to get x on its own. That's going to give us x equals 66 over 90. We are going to divide the top and the bottom by 6. And that is going to give us 11 over 15. And that is how we prove that. Question 16. Here is a speed time graph for a car. We have that here. Part A, work out an estimate for the distance the car traveled in the first 30 seconds. So if we go to the cheat sheet, well, the distance is going to be the area under the graph. The keyword here is estimate. We're going to draw, so it's not going to be exact if it's an estimate. We're going to draw a triangle using straight lines. And the area of this triangle, it's going to be the base times the height divided by 2. You should already know that bit. So we need to work out the area of the first 30 seconds here. So I'm going to draw a line straight up to the curve from 30, and I'm going to draw a straight line down to 0. The base of the triangle is going to be 30 seconds, and the height is going to be, I'm going to say it's going to be about 9. So remember, for the distance, we're looking for this area under the graph here inside this triangle. So it's going to be a half multiplied by the base times the height. Well, the base is going to be 30. The height is going to be 9. So it's going to be 30 multiplied by 9, which is going to be 270. And then a half multiplied by 270 is going to give us 135. So part B, is your answer to part A an underestimate or an overestimate of the actual distance the car travelled in the first 30 seconds? Give a reason for your answer. So if we go to the cheat sheet, well, there is a gap between the curve and the straight line we drew for the triangle. And we're going to ask the question, well, what does this indicate? For example, we have, if we just zoom in a little bit more, we have this little gap here in between the triangle that we use for the distance and the curve. And to summarize, I'm going to say it's an underestimate. The area between the triangle and the curve is not included to work out the distance. Okay, so for part C, well, Julian used the graph to answer this question. Work out an estimate for the acceleration of the car at time 60 seconds. Here is Julian's working. So the acceleration equals speed divided by time, and that equals 13 divided by 60, which gives you 0.21 with the 6 recurrent meters per second squared. Julian's method does not give a good estimate of the acceleration at time 60 seconds. Explain why. So if we quickly go to the cheat sheet, well, acceleration is the change in velocity divided by the time taken. So to do this, we would draw a tangent to the curve and work out the gradient. This would give us the acceleration. And to do this, we're going to need 2 points on the curve, and he's only really used 1 point. But he has not drawn a tangent to the curve, and that's all we need. Question 17, the histogram gives information about the distances 80 competitors jumped in a long jump competition. And we have that there, we have a frequency density table. Calculate an estimate, I'm going to underline that word estimate, for the mean distance. So if we go to the cheat sheet, we need to remember that the frequency is equals the frequency density multiplied by the class width. The mean is going to be f of x divided by f. We're going to use that in this estimation. Remember, the key word here is estimate, so therefore we are going to use the midpoint of the class width that we are given. F is going to equal the frequency, which is going to be the number of competitors, the number of long jump competitors. X is going to be the midpoint of the class width, or the average jump distance of the class width. And f of x is going to be the frequency multiplied by the midpoint. And this is going to be the estimated total distance jumped. Okay, so if you remember from the cheat sheet, the frequency is going to be the frequency density multiplied by the class width. The mean is going to be f of x divided by f. And I've just drawn this table here at the bottom, and we're going to use this to put some information in so that we can find, most importantly, this f of x and this f. These are the two that we need to work out at the end to find the mean. So first of all, we need to find the midpoints, which is going to be our x value. So what is the midpoint of this class width of 6.4 to 7.2? Well, that is going to be 6.8. Same with 7.2 to 7.6, that's going to be 7.4. 7.6 to 8.0, that is going to be 7.8. And 8.0 to 8.2, that is going to be 8.1. And for the frequency, we have the frequency density multiplied by the class width. So for 6.4 to 7.2, we know that this bar goes up to 10. And the class width, well, it's 7.2 subtract 6.4, and that's going to give us 0.8. And that's going to equal 8 people. So with 7.2 to 7.6, well, this bar here, the frequency density goes up to 50. And the class width is going to be 0.4. And that is going to equal 20 people. Again, 7.6 to 8.0, well, that goes up all the way up to 100. And again, we've got a class width of 0.4. So that's going to equal 40 people. And for the last one, we have this 8.0 to 8.2, and that goes all the way up to 60. But we have a class width of 0.2, and that is going to give us 12 people. Now, just to double check, we are told that there are 80 competitors in this competition, and so far we have 8 plus 20 plus 40 plus 12. Well, 20 plus 40 is 60, plus the 8 is 68, plus the 12 is 80. So I am happy with that. So to get f of x, we're going to have 6.8 multiplied by 8. We're going to have 7.4 multiplied by 20. We're going to have 7.8 multiplied by 40, and we're going to have 8.1 multiplied by 12, and you're going to need to calculate that for this. So now we have those values of f of x, and if we add them together, we're going to get a total value of 611.6. So remember, the mean equals f of x divided by f, so the total value of f of x divided by the total value of f, so it's going to be 611.6 divided by 80, and that is going to give us a value of 7.645. Question 18, the diagram shows a cube, right here. AH equals 11.3 centimeters, correct to the nearest millimeter. Calculate the lower bound for the length of an edge of the cube. You must show all of your working. So if we go to the cheat sheet, again, as I keep saying, draw on the diagram, guys, because trust me, it really, really does help. We need to ask the question, well, what is the lower bound of 11.3? And we need to remember that all of the lengths on the edge of the cube are the same size because it's a cube. So I put in this line A to H right here, and we are given that it's 11.3 centimeters, correct to the nearest millimeter. So if we look at this line here, well, we know that 11.3, it's closer to 11.3 than it is to 11.2 or 11.4. So we know that it's going to be in the range of 11.25 and 11.35. But as we are looking for the lower bound, we are going to choose this one, 11.25, and I'm going to put that on the diagram. So far we've used the lower bound of A to H as 11.25, and we're not really given any other information in the question. So you might be looking at it thinking, well, what do I do? What the hell do I do next? Well, this is where if you draw things, it can make things a little bit more easy. And sometimes you can say something that maybe you didn't say before. For example, if we have this triangle here, this FE to H, well, this is going to be it's a right angle triangle, which we have here. And same with this A to F to H. Again, this is going to be a right angle here. I'm going to put that in. So we can use Pythagoras to work some of these out, even though we don't have much to work with. So all of the green lines that I put in, they are all edges of the cube, so they are all the same size, even though this looks a lot bigger than this one, they are all the same size. And this blue one is a diagonal, and this red one is, we do know the size of this one, it's the lower bound, it's 11.25. So what I'm going to say is that x is the edge of the cube, and I'm just going to put those values on the diagrams that I have, and y is going to be the diagonal. So I'm just going to put this into here. So if we use Pythagoras here, we know that y squared is going to equal, put this into green, x squared here plus x squared here. And again, I can't do any more than that at the moment. With this one, if I just put that 11.25 from the diagram here onto here, well, because this is the long length, we can say that, well, 11.25 squared equals, it's going to be x squared plus y squared. And again, you might be looking at this, well, okay, what next? What do we do? Well, this is where you need to think a little bit outside the box, because can you say that here we have this y squared here and this y squared here, and it tells us that y squared equals x squared plus x squared. So we are going to sub that in to here. So it's going to be the x squared plus y squared, but we're going to change this for the x squared plus x squared, and that is going to give us 3x squared equals 11.25 squared. We're going to divide both sides by 3, and then we're going to square root both sides, so that's going to give us the square root of 11.25 squared divided by 3 equals x. And if you do that on your calculator, that will give you 6.495190528. Question 19, A, B, C, D, E, F, which we have right here, is a regular hexagon. I'm going to underline that word regular, with sides of length x. This hexagon is enlarged, center F, here, by scale factor P, to give hexagon F, G, H, I, J, K, this one here, this large one. Show that the area of the shaded region, this part here, in the diagram is given by 3, root 3, divided by 2, and then in brackets, it's very hard to say, p squared minus 1, close brackets, x squared. Okay, so we go to the cheat sheet. Well, the lengths of A, B, C, D, E, F are going to equal x, or all of them. Same with F, G, H, I, J, K, they're all going to be px because it's increased by a scale factor of p. The area of the shaded region is going to be the area of the large hexagon, subtract the area of the small hexagon. Any angle in a regular polygon is given by this formula where we have, when n is the number of sides, it's going to be n minus 2 multiplied by 180 divided by n. And we're going to use 6 triangles to work out the area of the hexagon. Okay, so what I've done here is I've put the length of x on here, I've put the length of px right here. Now we need to work out the size of these angles, and the angles in the large hexagon are going to be exactly the same as the angles in the small hexagon. Remember, it's a regular, I'm going to underline that again, it's a regular hexagon. So how many sides are in a hexagon? Well, there's going to be 6, so this n is going to be 6. So we're going to have 6 minus 2 multiplied by 180 divided by 6, and if you work that out, that is going to give us 120 degrees. I'm just going to put those in there, not on every one, but just to give you an idea. All of these angles are going to be equal because it's regular. So now we need to work out the area of the shaded region. Well, remember, it's going to be the area of this large hexagon, subtract the area of this small hexagon. I'm just going to work on the small one first because it might be a little bit easier to see. So I've split this regular hexagon into 6 equal triangles, and can you see that these lines, they're going to bisect these 120 degrees right in the middle? So for example, we know that these are going to be 60 degrees. And if this is 60 and this is 60, well, all of the angles in a triangle add up to 180. So this is going to be 60 also, and it's going to be an equilateral triangle. And again, this side is going to be x, this side is going to be x. So to work out the area of the small hexagon, I'm going to find the area of one of these triangles using this rule right here. The area of a triangle equals half AB sine C. And then I'm going to multiply that by 6 to get the full hexagon. So to work out the area of one of these triangles, we need, using this rule here, we need the angle in the middle of two lengths, and we have that. So we're going to have, well, it's going to be multiplied by 6 because there were 6 triangles. It's going to be 6. We're going to have a half AB. Well, A is going to be x, B is going to be x. So we're going to have x, x, and then the sine C, this angle in the middle, is going to be sine 60. And immediately, just to tidy this up a little bit, we have 6 multiplied by a half, so that's just going to be 3. X multiplied by x is going to be x squared. Sine 60, you can do this on your calculator if you need to. It's a calculator paper, but you should know that this is going to be root 3 over 2. And just to tidy this up a little bit more, this is going to give us root 3 over 2 x squared. And even though we're nowhere near finished at the moment, this should give you a lot of confidence, because if you look in the question, we do have this 3 root 3 over 2, which we have here. So I'm feeling confident now that I'm on the right track. Okay, so I'm going to do exactly the same with the area of the large hexagon. I'm going to divide this up into 6 triangles. And again, the angle will be exactly the same, because even though it's bigger, the angles, we're going to bisect these 120 degrees, so it's going to be 60 degrees. So it's going to be equals, so this time we're going to have 6 multiplied by, well, it's going to be a half. And then A in this example is going to be px. B in this example is going to be px. So we're going to have px, px. And then again, we're going to have sine 60. We're running out of a little bit of room. And again, just to tidy up, well, 6 multiplied by a half is going to be 3. Px multiplied by px is going to be p squared, x squared. And then the sine 60 is going to be root 3 over 2. And again, just to tidy this up and get the numbers together, that is going to give us 3 root 3 over 2 p squared, x squared. And again, if we look at this, what we are asked to show, we are pretty close now. We just need to factorize the right thing. So we need to have p squared minus 1 in the bracket on its own. So I'm going to factorize from this one. I just want p squared on its own. I'm going to factorize 3 root 3 over 2 x squared to give us p squared here. And then luckily enough, and again, it's looking very, very good. If we were to factorize 3 root 3 over 2 x squared from here, we would just have minus 1. And we are pretty much where we need to be. We just need to maneuver things around a little bit. So we're going to have 3 root 3 over 2, and then we're going to have the brackets in the middle. I think they did that just to kind of throw you off a little bit. It's normally you would have the x squared here with the 3 root 3 over 2, but I think they just decided to make it a little bit more confusing, to have the brackets in the middle. So I'm going to just put that x squared, instead of having it here, we're going to have it here. It's all going to be multiplied, so it really doesn't make much difference. But yeah, like I said, I did probably do that just to throw you off a little bit, but that is going to be our answer. Question 20, here is a list of 5 numbers. So we have 98 to the power of 53, 98 to the power of 64, 98 to the power of 73, 98 to the power of 88, 98 to the power of 91. Find the lowest common multiple of these 5 numbers. And if we go to the cheat sheet, well, 98 to the power of 53 is like 98 multiplied by 98 multiplied by 98 53 times. And then 98 to the power of 91, for example, is just the same, 98 by 98 by 98, 91 times. So if we use this logic, the lowest common multiple of all of these 5, it's just going to be this one. This is going to be a multiple of all of these. Question 21, 5c plus d equals c plus 4d. Part A, find the ratio c to d. So if we go to the cheat sheet, well, we're going to gather all c values on one side, or the d values on the other side, and then we're going to try and find out what values does this equation give for c and d, and a good hint here would be to flip the numbers when we're talking about ratios. Okay, so I'm going to subtract c from both sides to get 4c plus d equals 4d. I'm going to subtract d from both sides to get 4c equals 3d. And at this point, with regards to the ratio, you may be thinking, well, it must be c must be 4 and d must be 3. But actually, we need to flip these over. So what we're really going to have is we're going to have c to d. It's not going to be 3 for d. It's going to be 4. I'm going to flip it. And for c, it's not going to be 3. It's not going to be 4. It's going to be 3. And just to give you a bit of context, for example, if you imagine that, remember, these are equal. 4c equals 3d. So if we imagine there is 12 on both sides, well, c here is going to be 3, 4 times 3. And this d is going to be 4, 3 times 4, to give you 12 on both sides. That is why it is c is 3 and d is 4. So 6x squared equals 7xy plus 20y squared, where x is greater than 0 and y is greater than 0. Part B, find the ratio x to y. So if we go to the cheat sheet, well, we're going to get all values on one side, and then we're going to have equals 0 on the other side. This is a complicated quadratic to factor. So it's going to be a good idea to use split the middle term on these quadratics. And at the end, we need to remember that, well, x must be greater than 0 and y must be greater than 0. Okay, so first of all, I want to get this equal to 0 so we can factorize this. So I'm going to have 6x squared here, but I'm going to subtract 7xy and 20y squared from both sides. And that is going to equal 0. And what I want you to do for this, so it might look very confusing because we've got x squared here and a y squared here, and then an x and a y value here. What I'm going to ask that you do is that you just ignore the y's almost. I want you to think of this question in terms of x. This will help you out a little bit. And also because we have a complicated quadratic, it's going to be a good idea to use splitting the middle term for this. So these are going to be our combinations, and we need to add these together to give us minus 7. Well, the only one that I can say is going to be this one. So if we have plus 8 and minus 15, that is going to add together to give us minus 7. Okay, so we're going to have 6x squared, and this middle term, like I said, we're going to split this middle term, so it's going to become minus 15xy plus 8xy, and if we added these two together, it would just give us this again, so we haven't really changed anything, we've just rearranged it. Minus the 20y squared equals 0. Okay, so at this stage of the question, we're going to divide the equation up into 2, right down the middle, and we're going to factorize both of them, and hopefully we should have the same thing in the brackets. That's what we're looking for. So we have 6x squared minus 15xy. Well, I think we can pull out a 3 from this. This 3 goes into both of those, and we can pull out an x from those. And to get 6x squared, well, it's going to be 2x here. And then to get minus 15xy from 3x, it's going to be minus 5 multiplied by y. And over here, we've got plus 8xy minus 20y squared. We could pull out a 4. And we could pull out a y. So plus 4y. And in the brackets here, we are going to have, what, 4y. To get 8xy from 4y, it's going to be 2x. And then to get 20y squared from 4y, it's going to be minus 5y. And that's going to equal 0. And can you see here in the brackets, this is perfect. We have the same, we have 2x minus 5y in both brackets. This is perfect. So what we now have for this equation, we have 3x plus 4y. I'm going to change the color now just to make it a bit more clear. So it's going to be this 3x here plus the 4y here, everything outside of the brackets. And then just whatever's in the brackets, we just write it out again, just once. So as it equals 0, we can now say that, well, 3x plus 4y equals 0, or 2x minus 5y equals 0. Okay, so we're just going to manipulate this around a little bit to get what we want. So I'm going to say, well, 3x, I'm going to minus 4y from both sides. I'm going to divide by y on both sides. And then I'm going to divide by 3. And that is going to give us, well, x is going to equal minus 4, y is going to equal 3. Or we're going to have, well, I'm going to add 5y to both sides, so it's going to be 2x equals 5y. I'm going to divide by y on both sides to give us 2x over y equals 5. And I'm going to divide by 2. So that's going to equal 5 over 2. And if I go back to the top here, if you remember, x must be greater than 0 and y must be greater than 0. So in this one, we are going to have, well, it's going to be, with x to y, it's going to be minus 4 to 3. And with this one, it's going to be 5 to 2. And I'm going to draw a line through this one. X is greater than 0, so cannot be negative. And this is going to be our answer. Okay, that is the end of the paper, guys. Thank you so much for watching. I hope you enjoyed it. I hope you learned something. And if you have some exams coming up, I wish you the best of luck. Thank you.